So after setting the foundation for 10-base-2 networks in my last episode, I went right into testing my gear. But things didn't turn out as straightforward like with this NIC, which claims the broadcast MAC address as its own and hides from the configuration program. Interrupt conflicts, causing generic malfunctions, and my DOS boot floppies themselves running into conflicts with mTCP and Trumpet TCP for DOS. And if it weren't enough already with this guy here always asking for Windows Me, I also destroyed the wall when trying to mount a network rack. Let's talk about legacy network technology. I'm the Vintage Collector and these are my stories. With all the gear I've shown to you in my last episode, I thought to begin with this 80s portable, the Accton LA5040. This machine sports two ISA expansion slots, one for 8-bit and another for 16-bit cards. These are easily accessible from the backside once you remove this cover here. And as a first item, I want to see if I can get this Realtek network card to work. Maybe you remember the 386 where I had installed Windows 95 to earlier this year. I had previously installed this network card into that machine only to find obscure errors like this one, so I knew it needed some attention. Using those DOS-based boot floppies I created before, I should be all set and ready to have a more low-level look at this particular card. This card offers actually 3 configurative modes. One is to configure via jumpers only, one is software configurable via EPROM, and the third is ISA plug and play. Now I tried this one on Windows 95 in all 3 modes and it was actually somewhat detected, but it never worked. For my tests, I now tried both jumpers and EPROM mode. While in jumper mode I'll use RQ10 and iAddress 300 hex for testing. At least the Realtek 8019 chip is NE2000 compatible, so let's see what my general purpose NE2000 packet driver says. It reports all FFs for the MAC address. Now, the all FFs MAC address is the broadcast MAC address and the network card should never use this one. It's a good indicator something is wrong with this one, possibly a broken EPROM. As I had included the config and diagnostic tools on my floppies RZ8019 in this example, I wondered what it would report. But apparently it would always report not finding a suitable network card, and this wouldn't change no matter what configurative mode I tried for this NIC. As I had also asked the community, I got many different advices, from using the configuration tool, which I did, down to bad solder joints, but the majority setting on a bad ROM. Well, I won't throw it away yet, as it might be a neat thing to dig deeper on this one, but not for this time round. Another network card I own multiple units is the Kingston KNE 2021 LC, basically an NE2000 compatible. Using the provided LC tool, it is easy to inspect or change the IRQ or IA configuration if needed. And as you see, I just switched it to use RQ10. That's for the simple reason, as with the many systems I have, I'll always configure sound cards and network cards the same way, so I don't need to memorize it. I shall mention though that I'm always putting labels in place, just in case, also with the actual type of the network card, so I don't have to open a machine to see what's inside. It's that simple. And simplicity is key, especially when you're consuming services like the ones provided by today's episode sponsor, PCBWay. I had worked with PCBWay on various 3D printing projects previously featured on this channel, like this beautiful reproduction of a power supply cover and the drive sled for my SGI O2 workstation. Right now, I'm looking forward to the results of our current collaboration around turnkey PCB production and assembly services. And that was just about in time, as PCBWay cut their fees for PCB assembly down to $29 per 20 pieces, as I need just that electronic spare part to bring this IBM P70 back to life. So if you need services, PCBWay is here to make it happen. When I presented you my DOS TCP IP diagnostics boot floppies, I mentioned only briefly that it runs two IP stacks side by side, mTCP and Trumpet's TCP for DOS. I included the latter in particular to have a permanent ICMP responder, which mTCP doesn't provide. But there's one problem with that approach, which I had to specifically solve to make it work. Looking at this example here, you clearly see how I loaded the packet driver for the 3COM card. And that seems to be about right, as the DHCP request will indeed receive the offer from the DHCP server. So far, so good. But then, when exiting to the shell and trying to send a ping, it wouldn't work and I got only a timeout waiting for the ARP response. And that can actually mean multiple things. Either my ICMP packet is sent out, but I indeed don't receive answers because the destination is invalid. Or the packet is not sent out at all, which is why I don't receive an answer. Or, while the packet is sent out, it won't be received because of a resource conflict or a defective network card on my end. It's also possible to think about an invalid MAC address, as seen at the example of the Realtek network card before. So the easiest to rule out is the invalid destination, as I know for certain it exists. So I hooked up Wireshark to the repeater hub I've shown you in my last episode. Now, you do remember what I told you about repeaters and hubs and how they work, right? Right. They simply pass on every frame received on the wire through every connected port. And that makes capturing actually very simple, as I only need to hook up a monitor station and listen on the wire. During this early phase, I did lots of hardware swapping to rule out the hardware, so in the meantime the Kingston KNE 2021 was back to this machine, replacing the 3COM card. And going by this capture in Wireshark, I see two things happening while my ping is running. For one, I get to see the outgoing ARP request from the Kingston network adapter asking for the MAC address for the destination 912.168.100.254. ARP is short for the Address Resolution Protocol, and this is the foundation for making IP working, as every frame needs to carry the source and the destination MAC address in the header. So my machine was clearly performing the ARP lookup, and I also do see the ARP reply coming from the Cisco router. But the fact it happens multiple times in a row matches up with the observed behavior here when the test machine claims running into an ARP timeout. I know for a fact that I could send egress ping packets when testing this in VirtualBox. And I also know for a fact that I would receive ICMP echo response packets. So in order to nail it down, I ran the commands in sequence manually without autoexec.bat, and surprisingly, I started seeing the ICMP working right away. So what's going wrong here? Now, I had omitted something in this manual test scenario. I left out Trumpet's TCP for DOS. And the moment I would run it, ICMP stopped working. And it started working again the moment I unloaded Trumpet's TCP. So, for anyone using DOS back in the day, it may be obvious, but for me, whom professionally started only in the mid-90s, I never had to deal with the pure networking technology on DOS. In our present-day operating systems, the network stack is an internal part of the operating systems themselves. Long gone are the days when network stacks were provided by third-party suppliers, but that was really the case during the DOS era. Although DOS gained some kernel-level capability for supporting networks as early as with version 3.1, it never included a network stack itself. That one was provided, besides Microsoft, by many other vendors, be Novell but also Lantastic and Banyan Wines, just to name a few. These products would all be separately installed to DOS in order to provide the desired network functionality. However, DOS was not designed as a multi-user and multitasking operating system in the first place. By means of so-called terminate and stay resident programs, TSRs for short, one could sort of overcome this limitation to some extent by having background tasks running. However, the inherent design limitations showed everywhere, as many interfaces in DOS were built on the premise that they could only be accessed by one single application at a time. That's also true for the network packet drivers. Once loaded, they would expose the packet driver API on a defined software interrupt of 60 hex to 80 hex. If a network-enabled application comes, it would temporarily lock this software interrupt and thus the packet driver interface, so it couldn't be used by any other concurrently running application. Now, the problem is that while Trumpet TCP was running, neither of the CLI-based mTCP tools could acquire the interface exclusively. That's why the mTCP ping utility was unable to receive the returned ARP replies, as instead this would end up with the resident Trumpet TCP TSR. The solution to this problem is to use PKTMUX, a multiplexer for the packet driver interface. Once loaded, it allows coexistence of both mTCP and Trumpet TCP and makes things work the way it was intended. Needless to say, that's not an issue specific to the TCP/IP protocol. If I was using different IPX implementations concurrently instead, I would as well require a multiplexer in place, especially when memory resident applications are in use. And don't worry if you downloaded my DOS TCP/IP boot disks already at the time my previous video came out, the multiplexer was already in place by then. And that's also the reason why I started off with TCP/IP, because as an IP network engineer, it helped me a lot to have layer 2 and layer 3 protocols in place to relate to, as my main concern at this point was how to find out if my layer 1 and layer 2 gear is working correctly. And not all vendors ever provided any such diagnostic tools, like the one seen here for the 3COM 3C509 network card, as this of course also would have made my life much easier. But as you saw, I'm dealing with a multitude of different network cards by different vendors. And here's one thing to mention for the 3COM Etherlink 3. Although it seems to provide an automatic detection for the actual transceiver in use, or in other words, auto detection for twisted pair or coaxial cabling, it didn't seem to work and I had to statically configure it for the coaxial transceiver. Maybe that's a bug for that particular model, as for other 3COM cards I had, the auto detection worked just fine. My gear also included this network card by Accton. While my research revealed it was NE2000 compatible and it was actually detected by the general purpose NE2000 driver, it didn't work. Here again, visible by the ARP timeout we've seen before. By the time, I had the multiplexer already in place. Tracing in Wireshark did reveal nothing, so I was either having a broken network card again, or indeed an IO address or IRQ resource conflict. But which card was it actually? The markings on the board didn't really reveal too much. So I went out looking for various designations until I actually found the same card on eBay. And what luck, as the seller also posted an image of the driver disk referring to it as being the EN165X. Using that designation I then found the correct driver and the setup tool to use within minutes. Apparently, I had a similar issue with this 3COM Etherlink 2 to identify which exact model it was. But luckily, I found it very quickly on the retro web and eventually the fact that this one is the 3C503 network card. As it has an 8-bit ISA connector, it's ideal for putting into the IBM PC or PCXT. But apparently, according to this source, other 3COM cards are also good for running in an 8-bit slot, and we'll be looking at this one in an upcoming episode. For the moment, it shall be sufficient to say that using the correct packet driver, I could also verify this network card as being functional. Now, as mentioned in my last episode, I also had a PCMCIA adapter card for laptop computers. And in the meantime, I've even received a second one. Then, when looking after those machines, I found that I have now to go down the unpleasant route for finding the actual PCMCIA drivers for them, as neither runs Windows 9X, but rather DOS and Windows 3.x. And that alone justifies its own episode.
And what about Windows Me?
To be honest, I have only one system which has Windows Me on it, which is this Sony Vaio PictureBook. Unfortunately, the screen has suffered a bit from a screen privacy protector that was previously applied, but it still works. As for this adapter here, the ENW3500 by Planet, I had to provide it a driver to install. One reboot later and it would be ready to use. I had the PictureBook connected only to the Helicon portable via the 10BASE2 wire, with no connectivity to the rest of the network, so it wouldn't reach the DHCP server. Windows Me would then assign itself an APIPA IP address from the 169.254/16 prefix. And with the latest fix that I had applied to my TCP/IP floppies, which currently runs on the Helicon machine, it too uses now the correct APIPA network mask of 255.255.0.0 and thus can be pinged from the Windows machine. And maybe you still remember this compact IBM PC lookalike from my last year's episode. This machine, which features a passive backplane and uses a coprocessor board instead of a regular mainboard, has as well a NIC installed, though I never bothered yet to get it to work. But now again, I can simply set the IO address and the RQs using the config program, and voila, it seems to work as well. Then I wanted to bring that Toshiba T5200 onto the network. It was no big deal opening the backside, which revealed, as I had read in the system manual before, one 8-bit and one 16-bit ISA slot. Of course, I fitted one adapter card, though when trying to boot off my floppy disks, it turned out this drive is defective and may need maintenance, which is why I have to put this aside until later. Of course, all of those efforts only make sense when putting the network in place. So I organized a small 19-inch rack that would go underneath that table there. It was quite adventurous to drill those holes into the concrete walls. Maybe I should mention that my home museum is built into a former bomb shelter. In Switzerland, houses had to have bomb shelters built, so this is 50 centimeters of concrete wall. Actually, I expected it to happen, but some pieces will split away when drilling. It nevertheless upset me, as I of course had to fix it again. Anyways, at some point it was somewhat repaired so I could mount the rack. For For now, it'll hold just the power distribution and the 10-base-2 10-base-T repeater hub. I hope that at some point I can put a token ring multi-station access unit in there as well. For the moment, however, there's a more important question to answer. As this is a bomb shelter, I have no means of feeding a network cable into this room from the outside. So how to connect the museum LAN to the main network of my house? Anyway, that's a riddle to solve for an upcoming episode. At least, with all the steps done so far, I can assert all my gear is functional, and using my test methodology, I have enough confidence now to start looking into products like LANtastic, Banyan and Novell and the IPX protocol. What do you think about it? And what was your challenges, either as a retro computing enthusiast or maybe even as an actual user or admin working with this technology back in the day? Let me know in the comments below. I'm the Vintage Collector, and this was my story for today. Oh, and by the way, if you're asking yourself how to support me and this channel, consider looking on my wish list for retro gear or a channel membership subscription. This would allow me to bring you even more interesting topics in the future. Thanks for watching, and see you again next Sunday. Next time on the Vintage Collector. One might argue if DOS would have gained the widespread use it saw over 20 years, weren't it for Microsoft. But did you know that DOS actually started out as a clone of the CP/M operating system?
What is a local area network? I guess ever since we've had computers around.
Its inventor, Gary Kildall, later went face to face with Microsoft with its own DOS-compatible operating system, the RDOS, onto which even Novell had thrown an eye, ultimately culminating into the 90s OS wars.